Cetane number is very similar in diesel engines to the gasoline, the octane rating. So we have rating numbers. They go, you try and target about a 45, 50 typically. And you'll hear lately, there's been a lot of development in what we call converting coal and coke, and because there's huge, I mean, the States has probably one of the largest coal deposits in the world. And we can convert coal to gasoline and diesel by pretty much by some interesting chemistry that's been proven and available today. In fact, Houston actually has a project, coal to liquids, where you gasify the coal by basically burning it with air and steam to produce carbon monoxide and hydrogen. And we call that a synthetic gas because you synthesized it. And then you run that through a special catalyst Germans invented known as Fischer-Tropsch. And you can actually polymerize this carbon monoxide with the hydrogen to produce gasoline and diesel. And so the only problem, of course, is it costs so much. It's more expensive than producing from oil, because oil is still so cheap. And but the big thing is that it has very high octane and cetane ratings that they're thinking of using it as a blending component, just the same. You remember I was talking about the MTBE, and we had 10, 11%, and it boosts the rating. And so that's really what they're thinking of doing. So the cetane number, it's an indication of the ease with which an engine or a diesel engine or diesel fuel can be started in an engine. So the higher the better. It's got, again, low temperature stability and smoother combustion with less smoke. It doesn't smoke as bad if the ratings are high. Volatility, it relates to the fuel's characteristics, burning, and then the ignition and operating and combustion efficiency. These are some pictures comparing, the volatility versus the different fuels. So the diesel 1 and 2 has very low volatility because you're not vaporizing it in a diesel engine compared to gasoline. Again, low temperature fluidity. We can probably move a little faster through these. They blend different diesel products to produce different mixes.
What's the difference between diesel 1 and diesel 2?
They're different engine sizes. Diesel 1s, I think, are for the smaller engines in cars. Diesel 2 are more the power, so the quality is less. It's not as demanding as what we call ultra-low sulfur diesel today. Those are predominantly used for power generation. Up on the North Slope, diesel, in fact, I don't know if anybody working on the ConocoPhillips, the ultra-low sulfur diesel project. It's kind of interesting. The economics show, well, they use diesel for generating power in Alaska. I mean, that's without a doubt. So there's a lot of diesel engines all over the place. They consume roughly somewhere around 3,000, 4,000 barrels a day of diesel. And we looked into the economics of building an ultra-low sulfur diesel plant versus fractionating the diesel, sending it down to California and maybe Washington, converting it to ultra-low diesel and then shipping it back up again. And we found out it'll cost about another buck and a half. So you're paying about $2.50 today, plus another $1.50, would be $3-4 a gallon. Okay? And if you compare that to building a little diesel hydrotreater to hydrotreat the 3,000 barrels that we need, it is more cost effective to build a hydrotreater. That's really the economics of that hydrotreater. That's what justified building that plant. Okay? Again, gravity is important, that we control the gravity. The greater the gravity, the better the higher the API. Viscosity, again, because you have to pump that fluid around. Sulfur is important, and as we said, now the mandates are to reduce the sulfur below 15 parts per million. I think I have examples of. I'll leave this. We look at water. We have to get the water out so it doesn't freeze on us, and then cleanliness. filter plugging and so on, because it's kind of bottom of the barrel material, so you're trying to maintain the quality of the diesel. Fire hazards in flash points. The flash points are an interesting property. Flash points is an interesting property. It's a simple test. You put the fluid that you're testing in a little beacon, and you heat it up, and you're measuring the temperature. It's got a thermometer sticking in it, and then there's a little flame that's applied to it. And what we do is we raise it 10 degrees, and we dump the flame right into it. If it doesn't catch fire, then you heat it up 10 more degrees, and you keep heating it until it gets to the point where if you hit it with the fuel and it catches fire, that's your flash point. Okay, so obviously lighter components will just burn right away, and it has very low flash points. But with diesel products and jet fuels, the flash point is an important characteristic because it measures how much light material is in that mixture. And you want to try and eliminate, they want to try and really minimize the flash point, because you don't want too many light ends in your gasoline, or in your diesel. Otherwise, when you're compressing, it'll start igniting before it really reaches its full stroke. Okay, and that's an example of how do you take, move gasoline from one engine, from the tank, all the way to an engine. You go through all these different steps before it really gets to your tank, and so it makes you wonder, what's sitting in everybody in all those terminals and the bottom of all those tanks after so many years. Trends is decreasing the amount of straight run distillates, because the cetane ratings are low, and so increasing the use of cracked material, higher density, lower cetane quality, increasing additives, flow improvers, cetane improvers, stabilizers, and detergents. There's a diesel engine, impact on engine, and you want to try and minimize the emissions. Everybody sees this, but I guess lately you've noticed that the plumes really have kind of diminished. It's not as bad as it used to be, and the reason is we have ultra low sulfur diesel now. It's been mandated since '06, last year. Yeah.
How does biodiesel compare to...
Biodiesel is a very high quality diesel because it doesn't have any sulfur, and it has very high cetane ratings. So. But the volume is still very low. I mean, even if somebody was saying if you convert all the corn into biodiesel, it'll only satisfy maybe about 3 to 5% of the total diesel consumed in the United States. So, but it's, as I said, they use it. It's a good blending component to improve your cetane. Most of the gasoline, the cetane numbers, this one doesn't show. These are different emission standards, and there's a lot of research going in by EPA and the industry to improve on the quality of the diesel fuel, of the fuel itself. Gasoline specifications, now these are the latest. 1990, that was the reported. You look at the RVP and you'll see it's going down. So the future now, right now actually, this was done a few years ago during the Clean Fuel Program, and we were looking at 6 to 8. The aromatics are, I think, still at 35%. Benzene is still limited to 1 volume percent. Olefins up to 10%. Oxygen, typically 2.8%, 2.7 max. And then the sulfur is, the 30 is average, max allowable is 80. But the whole blend really has to be about 30 parts per million of sulfur. Diesel specs. Again, the cetane, carb diesel is at 48, but ultra low sulfur diesel brings that spec up to about 55. The T90 is the boiling range at the 90% point, and we used to be able to go up to about 640 degrees. What that means is that you can cut a little bit, you can actually produce more diesel out of a crude oil cut. Now they're limiting it to 608. It's really how much heavy material, and that's the heavy material that cracks in these engines at the high temperatures and forms the black plume. So they try and reduce that end point. What did you do? No. Density, aromatics, Polyaromatics limited to 10% total aromatics. And this is where, and then sulfur, 15 parts per million. So the biodiesel actually has much higher, maybe 50, 60, actually it's got 70 and 80 cetane ratings. So it's an excellent additive to boost and bring up the cetane ratings to about 55%. You guys should give yourselves a hand for staying awake. No? That's it. We finished actually in record time. Last time we finished around 7:50.